Hello everyone, welcome to Prakriya Educations. I am Uma Mallikarjuna. In the last module, we had discussed about the basic concepts of relations that you had already learned in your class 11. In this module, we shall enter into the topics of the second PUC relations and functions and start with the topic types of relations. In this module, we shall learn about the void relation, universal relation, and the identity relation. The first type of relation is the void relation. Void relation can also be called as null relation or even empty relation. If R is a relation on a set A to the set A itself and no element of A is related to any element of A, then you can call the relation as the void relation. Let us have a small example. If I am taking a set A which is equal to, and let me define the relation R as A, B such that the difference of A and B should be equal to 10. Fine. If you are taking any two elements from the set A and subtracting those two elements, you need to get 10. This is how I have defined the relation as. Now try to find the Cartesian product of the given set, that is A cross A. Since A is consisting of 3 elements, the number of elements in A cross A will be equal to 9. 3 into 3, which will give back us 9. Now let us try to write the relation R in the roster form. Then you get, take any two elements of the set A because the relation R is defined from the set A to the set A. Take the arrow diagram. Now connecting two elements according to the given relation, 2 minus 2 gets back 0 and it does not satisfy the given defined relation. Then 4 minus 4 no, 6 minus 6 no. You take any two elements, the difference of those two elements will never give me 10, and hence you can tell that, you can see in the arrow diagram that you cannot connect any two elements of these two sets, and hence the roster form of the relation R will be an empty set or a null set. You already know that null set is a subset of any set A, and hence even now you can tell that the null set will be a subset of A cross A. And therefore now the relation R that we have got is nothing but a null relation. R will be equal to a null set, and hence such type of relations may be called as null relation, empty relation, or void relation. Look at the second type of relation, universal relation. Again, take the same relation R on the set A to the set A itself. Then if each element of A is related to every element of A, it is completely the opposite of the null relation, then such a relation can be called as the universal relation. Let us again understand this using a small example. I shall take A is equal to, I'll take the same set 2, 4, 6 and define the relation R to the set A from set A to the set A itself. Then R is equal to, I am defining relation R as A, B such that modulus of A minus B will be always greater than or equal to 0. Okay, this is how I have defined the relation. Now we shall understand this using an arrow diagram. Now 2 minus 2, modulus of 2 minus 2 gives us 0. The condition is modulus of A minus B should be greater than or equal to 0, and hence this is satisfying the given relation, and hence I can connect these two. In the similar pattern I can even connect 4, 4 and 6, 6. Now if at all we take these two elements, check out 2 minus 4, which gives us modulus of minus 2, which is 2, and again greater than 0, again satisfying the given condition, and hence you can connect 2 and 4. In the same way you can even connect 2 6, 2 4 2, 4 4 has been connected, 4 6, and in the similar fashion 6 2 and 6 4. Look at this arrow diagram and this arrow diagram. It's completely the opposite one. Here no elements has been connected, but here all the elements are connected, and hence this kind of relation is called as the universal relation. And you also know that every set is a subset of the same set again, and hence I can now tell that A cross A will be also a subset of A cross A. The set is a subset of itself, and hence now the relation R is nothing but A cross A. Look at this. Here the relation R is equal to a null set, but here the relation R is equal to the Cartesian product of the same two sets, that is A cross A. You can look that the null relation is a smallest relation and the universal relation is the largest relation that you can get. And hence you can call the void relation as well the universal relation as extreme relations. The next one is the identity relation. Let A be any set, then the relation of this kind is called an identity relation if every element of A is related to itself only. Let us have a small example. If A is a set 1, 2, 3, and if I am defining the relation on A as R1 is my relation, and I am telling the relation is of the form 1, 1, 2, 2, and 3, 3. Such type of relations are called as identity relation. You can check in the arrow diagram. If I am having two sets A and A, now connecting as per this relation R1, now we get 1 is connected to 1, 2 is connected to 2, and 3 to 3. Such kind of relations are called as the identity relations. Now if I am having a relation of this sort, is this an identity relation? The answer is no. Because the condition is, if you are having 3 elements in the set A, all the 3 elements should be related to itself. Only then you can call the relation as the identity relation on the set A. And I shall give another example, R3. Now I hope you can guess it. This relation is also not an identity relation because 3 is also an element of A, but 3, 3 is not in the relation R3, and hence this is also not an identity relation. If I am writing another relation R4, now look at this relation. Yes, as per my definition, all the elements of A are connected to itself, but in this relation you can observe that there are some extra elements such as 1, 2 and 2, 3. Now look over for the definition. Every element of A is related to itself only. You shouldn't forget this, itself only, and hence these two elements should not be there in the identity relation, and hence you can conclude that even R4 is not an identity relation. I hope you're clarified with the identity relation. Be careful that the like ordered pairs only the like ordered pairs should be there in the identity relation, and unlike ordered pairs should not be there in the relation. Only then you can call a relation from the set A to the set A as an identity relation. I hope you enjoyed the video. Please don't forget to like, share and subscribe. Thank you.